we're going to talk about finding slope and rate of change today. Okay? Slope and rate of change. You have done slope and rate of change before. Okay? When we do slope, how do we find the slope of something? It's what over what? How do you find the slope? It's what over what? Rise over run. Change in y over change in x, right? Change in y over change in x. So slope, the slope m of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. So I take y2 minus y1 over x2 minus x1 to find my slope. And remember, when we have an equation of a line, what form is it in? Y equals what? Mx plus b. M being my slope, okay? And b being my what? Y-intercept, where it crosses on the axis, okay? So if I am going to find slope today, I simply take the change in y over the change in x, okay? Rise over run. A skateboard ramp has a rise of 15 inches, a run of 54 inches. What's its slope? What do I need to do? Rise over run. So I'm doing rise over run.
If every question was like that, it'd be serious.
What is rise over run in this case? Can that be reduced at all? No, so we just leave it. Okay, that's a very simple one. Just get us warmed up. You don't have to do any math. Okay, but don't overthink the simple ones. Okay, if the directions give us something where it says it rose 12 and ran 14, what's our starting point if it doesn't tell us? 0, 0. So don't overcomplicate things.
It can be simple.
Can it be simplified? Okay, to what?
3 over 8.
5 goes into both of them?
3.
You said 3 over 18.
I mean 1 over 18. Not 1 over, hold up. 3, I don't know, 3 goes into both.
That's what I said, so if 3 goes into both, it's 5 over 18. There you
Yes.
go. Okay, so
That's-
it does reduce, always reduce down, so it's 5 over 18. Don't forget to check that.
And don't listen.
And don't listen to Kate. Okay, what is the slope of a line passing through the given points, -1, 3, and 2, -1? What do I need to set up? Yeah, rise over, change in y over change in x, okay? So here are my 2 points, right? I need you to show me work. What goes up top? What do you want to do? -1 minus 3 over what? 2 minus -1. What is -1 minus 3? And what is, oh, look, we have a flip, is that what Mrs. McCain says? I say ding, ding, is it positive? 2 negatives is a +2. What's 2 plus 1? So my slope is, which is A, yes? Can you handle doing that? How do we feel about slope? Good? Okay. Without graphing, you guys are gonna come to like those words when I tell you don't have to graph something. Without graphing, tell whether the line through the given point rises, falls, is horizontal or vertical. If it's rising, what does that mean about its slope? It's what? It's positive. If it's falling, what type of slope does it have? Negative, okay? We fall down, that's a negative thing, okay? If it is horizontal, what type of slope does it have? If it is horizontal means this way, right? Okay, listen, if I have a line that's this way, okay, I can walk across that line, right? Mrs. McCain says it this way. I can walk across that line.
If you were scholar.
Is there a rise or a fall? No, so what's the slope? 0. 0. 0 slope. It has 0 slope.
The
Okay.
word is death.
So this is fall, right? This way is rise. That way is 0. What about this? Can you walk on one that's vertical? No, so what's the slope?
Undefined.
Undefined. Undefined. Okay? So you have to be able to identify those 4 types of slopes. If we're doing it without graphing it, what do we need to use to do that? The slope formula. Yes, that's the only other way to go, okay? So let's do the slope formula for this one. Slope formula says the slope equals change in y over change in x. So you have to subtract y from y and x from x. So how am I gonna set it up? 1 minus 1 over what? Okay, negative 5 minus 3. So I get 0 over negative 8. If I have a 0, I can't write. If I have a 0 up top, what does that mean? What? The slope is 0. So what type of line does that mean I have? Horizontal. If the 0 is up top, it's horizontal. Okay? Part B. How do I set this one up? Okay, negative 4 minus 0 over what? 2 minus negative 6. So I get negative 4 up top on bottom. Ding, ding. I get 8, right? What does negative 4 over 8 reduce to? Negative 1 half, yes. Rise, fall, yes, rise, fall, 0, undefined, which one? Fall, beautiful. Okay, here, slope. What do I need to set up? Someone besides these two. 8 minus 3, good. And on bottom what? 5 minus negative 1. 8 minus 3 is 5, yeah? Add 6. 5, 6, is that reducible? Nope. Rise, fall, 0, slope undefined. Rise, beautiful. And last one, we set up slope equals negative 1 minus 6, right? Over 4 minus 4. So negative 7 over 0. Well, what is wrong with that? You can't have a 0 in the denominator spot, which means it's automatically undefined, which means it's a vertical line, right? Oops. This is vertical. This one is rise. Oh yeah, rise, fall, horizontal. Okay, beautiful. Can you handle doing that? Doing that nice little formula. Good, because we are halfway through with this lesson. Okay, the other thing we can tell with slopes is if lines are perpendicular or parallel to each other. Okay, this should all be reviewed right now, yeah? If my lines are parallel, they have the same exact slope, same slope. If my lines are perpendicular, they are the opposite reciprocals of each other, meaning if one slope is 5, the other slope is negative 1/5. If one slope is negative 2, the other slope is 1/2, opposite reciprocal. So when I multiply them together, I will always get negative 1 if I multiply the two slopes together. That's a way to tell. Perpendicular creates what types of things? When something's perpendicular to another line, what does that mean? What type of angles, more specifically? Right angles. I get 4 right angles. So they cross 4 right angles, okay? If my slopes are equal, are the same, they're parallel. What do parallel lines do? They never touch each other, okay? So we can graph them, or we can simply put them into the formula for slope and figure out what each slope is and then compare that way. Don't have to graph. Beautiful, okay? So, they're gonna give you problems like this in the book, where they say line 1 goes through points negative 2, 2, and 0, negative 1. Line 2 goes through negative 4, negative 1, and 2, 3. Tell whether the lines are parallel, perpendicular, or neither. Okay? So what would be the quickest way to solve this? Find the slopes. Why graph it when I can find the slopes? Okay? So, slope of line 1 right here equals what? How do I find that? Talk to me. Set it up for me. Good, negative 1 minus 2. over what? Over 0 minus -2, yeah? -1 and -2 gives me -3. This gives me +2, okay? Then I need to come down here and I need to find the slope of line 2, yes? Slope of line 2. How do I set that up? 3 minus -1, good. Over 2 minus -4, yeah? This gives me 4 up top, and on bottom it gives me 6, which gives me 2/3. Are those opposite reciprocals or are they equal? They're negative reciprocals or opposite reciprocals of each other. So what type of slope or what type of line do I have? Perpendicular. Or you can put this sign, I don't care. You can give me symbols or words. Cool? Now, over here, line 1. 1, 2, 4, -3. Set that up for me. How we want to do that? Find the slope. Good, -3 minus 2. And it's over top of 1 minus 1. Beautiful. -3 minus 2 is -5, yeah? 4 minus 1 is 3, yes? So -5/3. Always check what I'm doing too, because sometimes I make mistakes. Okay, and the slope of line 2 would be what? How are we gonna set that up? -2 minus 3 over -1 minus -4, yeah? -2, -3 is -5. This is a ding, so I get 3. What do I notice about those? They're the same, so they are parallel. I can even just put the parallel sign too. Cool? Questions thus far? We all following? We all doing okay? We're gonna use that slope formula quite a bit today, yes? Okay. Now, I think we just have 1 or 2 more things. One more thing? One more thing. Okay. Oh, I gave you this and then we have one more problem. Rate of change, okay? Slope can be used to represent an average rate of change or how much one quantity changes on average. So when they're asking you for the rate of change of something, like in a company, okay? Your profits go up and down, right? They're gonna ask what is the rate of change. They're asking you to find the slope of their profit line, okay? When trees grow outside, you know, what is the rate at which they're growing? What's the rate of change over the years? Things like that. Does that make sense? So rate of change is your slope, okay? Relative to the change in another quantity, a slope that is a real life rate of change involves units of measure such as miles per hour, degrees per day, yeah, all those type of things, okay? So rate of change is your slope. So then they give us like a real world scenario. Use the diagram which illustrates the growth of a giant sequoia, yes, thank you, to find the average rate of change in the diameter of the sequoia over time. Then predict its diameter in 2065. Okay, now, this one, okay, this was taken when this was in 1965, it's 137 inches in diameter. Fast forward to 2005, it's 141 inches in diameter. How can we find the rate of change with that? How can we find the rate of change with that? Did they give us enough information? I'll tell you they did.
The years over the growth, or growth value.
The years over the what? Okay, over the diameter, I can't speak, I'm sorry. Yeah, let's do diameter over time, okay? Diameter over time. So if we choose the diameter over the time, okay, we can find our rate of change that way. What is my diameter? 141 and 137, right? Okay, so I can take 141 hundred and 41 inches minus 137 inches over my diameter, oh, that was my diameter, over my years, correct? And you have the year 2005 over 1965, right? What happens when you subtract those things? What do I get? 141 minus 137 gives me, this should give me 4 inches, right? And this is the years. What's 2005 minus 1965? 40, and this is 40 years. Can this be reduced to what?
110.
1/10. So it's 1 inch for every 10 years, yes? Does that make sense? Okay, 1 inch for every 10 years. Or 0.1 inches per year. You can rewrite it in that if you want to write it as a decimal. So now they want to know, what's the diameter going to be in 2065? How can I set that up? How can I set that up? Multiply by what? Why 6? By 60 years. How'd you get 60 years? Beautiful. The last year we had data for was 2005. The new year we want is 2065. There's a difference of 60 years between those. So if I take 60 years and multiply by that 0.1, okay? So if I take this difference of 60 years, okay? If I take that 60 years and multiply it by 0.1, which is this right here, 1 inch in every 10 years, what do you end up getting? 6 inches, yes? Okay, so 6 inches. But that's not the answer. The answer isn't that it is at 6 inches. What's the answer? 147 inches. I have to come back and add it to this right here. So 141 plus the 6 equals approximately 147 inches in 2065. So if it continues to grow at the same rate that it's been growing from 65 to 05, from 1965 to 05, then it should be at 147 inches by 2065. Does that make sense? Okie dokie. Can you stop that? Okay, I will give you homework.